The amount of time per workout an athlete uses stair climber is normally distributed. The mean is 25, and the standard deviation is 5 minutes. So then the question is part B, what's the probability that a randomly selected athlete uses a stair climber for between 25 and 32 minutes? Okay, so first of all, once again, let's make let's represent visually with the diagram what's going on here. So what's going on here is we know that we have a normal distribution. We know that the mean is 25, and we know the standard deviation is 5. So let's draw the picture for that situation. There's my normal distribution. Z always has a score of 0 in the middle. And the mean, and we're talking about the distribution of data values, and that's X. And the mean for that is 25, so 25 goes in the middle. So what is it asking us to find? So it says between 25 and 32 minutes. So we've got to mark off those individual data values on the picture. 25, hey, has happened to be the mean, that's already marked off. We also have to mark off 32. So the thing that we're being asked to find, I remember that this whole thing up here, probability and area, which we think of as the same thing. Okay, so we're being asked to find that business in there. So that's the question, that's all the given information represented now on the diagram. So first thing first, we're given X values and we're trying to find areas. Using StatDisk, we first have to convert X values into Z-scores, and then from Z-scores, we can figure out the area, or in this case, the areas. Okay, so notice that StatDisk does not tell you the area between. So there are some software stats applications that will tell you a between area. A lot of them, however,
when it comes to the central option, because that's what I was putting in.
That's
I
not
feel like
it.
the central.
And that is not it. So yeah, so yeah. Later on, we'll talk about what central and two-tail means. But this is a between area. So for between area, notice that we can't do a between, so what can we do? Well, notice that when you mark off a between area, it actually defines 3 different areas. There's the between, which is the thing you're trying to figure out, but what else is there? There's an area to the left, and there's an area to the right. And if you can figure out the area to the left, the first area, and you can figure out the third area, that area to the right, then what's quote unquote left over must be the area between.
So you would subtract the left and the right?
From 1, because the total must be 1. So I'm going to mark these as A, B, and C. So here's A, here's B, and here's C. So let's now sort out A. So A has to be the area to the left of 25. Now I'm going to do this the long way, but then I'm going to show you a shortcut. So first we have to find the Z-score. So, well, lucky for us, 25 just happens to be the mean. It's in the middle. We already know the Z-score. The Z-score has to be 0. So punch in the Z-score. The Z-score is 0. Click evaluate, and you get, oh, look at that. The area is 0.5. So we did not actually, let me just do this. Okay. So we did not actually need to use StatDisk to figure that out. Just look at the picture. The midpoint, because the normal distribution is symmetric, give or take my amazing drawing skills, the midpoint clearly divides the whole thing in 2 equal halves. So clearly, the area to the left must be 0.5. Okay, next, we're going to find C, the area to the right of 32. So the first thing we have to do is figure out the Z-score.
Wait, sorry, why did you say that the area has to be 0.5?
Because what is true about this spot right here? Look at the picture.
It's the center of everything, so you divide it.
It's the dead center of a symmetric thing, so it divides it in equal halves. It's like if someone drew a line down the middle of your body, from the middle of your forehead down to the ground between your heels. It would divide you into, I'm approximating, equal halves. If that doesn't make sense to you, that's okay. You can just plug the value in, but you'll get, anytime you plug in a z-score of 0, you're going to get 0.5 for the area. Just thinking about the picture. This half and this half are the same. That's one of the fundamental properties of normal distribution. It's symmetric over the, from the middle. Okay. So next we're going to sort out, at x equals 32. So at x equals 32, what's the z-score? Again, the formula for the z-score, x minus mu over sigma. So the x value here is 32. The mean mu is 25, and sigma was 5. So that gives you 7 over 5, which is 1.4. So we now figured out that, I forgot to do it in purple. Okay. That this z value is 1.4. And so now we can punch that in. Z of 1.4, what do you get? We know the area to the left and the area to the right, but we know that what we need is the area to the right. That is 0.0808. Okay. And now again, we use the basic property of probability, which is that total probability must always equal 1. So 1 must equal 0.5 plus b, which is the probability that we're trying to figure out, area slash probability that we're trying to figure out, plus 0.0808. And now just solve for the thing that we're trying to figure out. So b equals 1 minus 0.5 minus 0.0808 equals, with the calculator, it'll tell you that's 0.4192. So a between problem is actually using our normal tools like either the table or StatDisk or Excel. It's actually a longer problem because you actually have to do a couple little problems in the middle in order to get the final answer. And then let me just mention for clarity, StatDisk is the only one that gives you, once you plug in a z-value, it's the only one that gives you all these different probabilities all together. A lot of the tools like Excel only give you the area to the left, so you'd have to adjust your approach to doing it that way. However, I have a feeling that now everyone has seen how StatDisk is and how easy it is to use. I have a feeling almost everyone's going to switch to StatDisk. It's just a hunch.